Right, everyone. So, welcome. I will be teaching Module 5 this week. So, Module 5 is all about index numbers. So, what are index numbers? They are basically numbers that represents percentages. They're basically percentage, but without the percentage sign. So, what do you use it for? You actually use it to compare the percentage change of one or more items from one time period to another. So why convert data to indexes? It's convenient to express change in a number in a diverse group of items. So if you want to express the change in prices of oil over 1990 to 2000, you can use index numbers and it'll be easier to see. Okay, so it also makes us, you know, how do you say it? Oh, it's easier for us to see trends, basically. So, especially if the numbers are large, because like, say you have like percentage price data of gold per kilogram from year 2010 to 2020. Like the numbers are so big. So if they aren't, expressed in an index number, you might miss like small and meticulous differences. So yeah, there are two types of price indexes. Sorry, A is unweighted and B is weighted. So I'm going to discuss them one by one. So unweighted indexes are easy. Number one is simple index numbers. So P, or the index number, is PT, or the price in the current period, not current, period of interest. So basically, what is period of interest? Say you have data of 2010, 2020, 2011, 2012, right? And say the PO, PO will always be given in the question, so don't worry. Say 2010 is the PO, and you want to get the index number for 2012, right? So this is basically your PT. Okay, so if you want to get index number of 2012, say P2012, right? So that's basically PT, or the price of 2012 over the price in uh, price in 2012 index here over price in 2010, because 2010 is the base number, right? So basically that's it. And if you want to do it for 2011, just change this into 2011. Let me erase that. If you want to change it to 2011, that's easy. Just use P2011, right? So that's about it. So number two is simple average of price indexes. It's basically just the average of all the price indexes. Just sum them all. Here there's the sigma symbol, you can see, and divide it with the number of items. So that's it. It's just a simple average equation, right? And what's an aggregate price index? So basically they are price of items in the group that are totaled for both periods and compared. Okay, this will be quite hard to understand if I just say it now, because you don't have an idea of what you can use it for. So we are going to discuss that in the sample question, so don't worry. So second one is weighted. So the first type of weighted index, there's less pairs, and the second one is the Pache method and last pairs method. I don't know how to say the first one. So they both have their own advantages and disadvantages. Please memorize them. Do not memorize, just understand them, because according to my experience, they're going to come out in midterms, either for your lecturer, from Miss Sandra, or from my side. So just remember that theory questions will most definitely come out. So just remember the advantages of flash pairs. Because it requires quantitative data of only base period, it can conclude into meaningful comparison over time, because you're comparing it to a past period. So you can see like from the past how much has it changed, right? And changes in index can be attributed to a change in price. So disadvantages, this will come out more often. The disadvantage of each method, it doesn't reflect changes in buying patterns over time. Also, it tends to overweight Remember this, it overweights goods whose price increase, right? Remember, it overweights prices of goods whose prices have increased. And this is the formula. It's just the sum of PT, which is the price in the selected period, times quantity 0, the base quantity, divided by the sum of P0 times Q0 times 100. So that's the index. And for partial method, the advantage, it uses quantities from the current period. So it reflects current buying habits, right? It doesn't reflect changes over time, but it reflects current buying habits. And it is the disadvantage is it's impossible to attribute changes in the index to changes in price alone because there are multiple factors, right? And it tends to overweight the goods whose prices have declined. So it's the exact opposite of last pairs. And it requires the prices to be computed each year. So basically you can see that the disadvantage and the advantage of each methods. So now you have to memorize that. So this is the formula. It's similar to last pairs, but look at that. It uses quantity T, QT, which is the quantity from the period that we chose, right? So for last pairs, we use Q0, and for partial, we use QT. And this is Fisher's ideal index. It basically just combines them all together. So after you get last pairs and partial, you time them all together, you multiply them, my bad, and then you square root them. There you can get Fisher's ideal index. And C's value index. Oh, yeah, my bad. This is the third type of index. So there's not just two types, there's three. In a value index, changes in both the price and quantities are considered. So the formula is V equals to the sum in PT times QT divided by the sum of P0 times Q0 times 100. Of course, because percentage, right? Index numbers are percentages. So this is a sample question we've all been waiting for. This is the table. They gave you 3 items: hot dog, yogurt, and soda, and the year 2017 and the year 2018. If you are supposed to find the price index for 2018, of course, because it's for 2018, the designated year is 2018, hence the base year, because there's no other choice. It's 2017. All right, so simple index is easy. Basically just the sum of all the prices divided by the sum of all prices in 2017 times 100, right? If you're confused why it's 9 per 6, basically for 2018, if you add this up, it's 450 plus 150 plus 300, that's 900, all right? And if you add this up, you get 600. So it's 9 per 6 times 100, you get 150. So basically prices have increased 1.5 times compared to 2017. That's how you use index numbers, right? You know straight away of the price increase. So this is last pairs. For last pairs, you can see, right? The formula is the sum of PT times Q0 divided by the sum of P0 times Q0. So first you have to time them one by one. You have to multiply them one by one. Okay. Right. So I don't know why the okay, just follow this one. So 4.5 times 150, 4.5 is the price in 2018. I guess this is supposed to be point, and point because I don't know. Let's just follow the sample questions, okay? Point. So it'll be impossible for a hot dog to be priced $450, okay? So $4.5 times 150 because that's the quantity in 2017, right? And for last pairs, you have to use the base quantity, which is 2017, the base year. And 1.5 times 50 for yogurt, and 3 times $2 times 125 for soda. You get 125 for the top part of the fraction. And for the bottom, you just have to do the same thing, but with the 2017 column. Just 3 times 150, 2 times 50, plus 1 times 125, you get 675. So with last pairs index, you just do 125 divided by 675 times 100, you get 166.67. Okay, now we have to count Pasha. For Pasha, we use current quantities, right? So it's basically this quantity. So 4.5 times 150 plus 1.5 times 100 and blah, 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 blah. You should know this by yourself right now. By now. 675 plus 150 plus 225, that's 1050. And the second one is 2017 times quantity 2018. So 725. So 1050 divided by 725, you get 144.83 for the index number. And now we have to see, we don't have to, but I just want to see that. You can compare last Paris and Pasha, right? They're both the same set of data, but you can see with last Paris, the index numbers overweight goods whose prices have increased. If you can see here, the index numbers for last Paris is considerably bigger than Pasha because the prices have actually increased. Okay, so this is Fisher's ideal index. It's basically a combination of both, right? It's supposed to be balanced. So 166.67 times 144.83, you get 155.36. Then now value index for 2018, which is current divided by base, PQ current divided by PQ base. You get 155.156, which you can see is quite similar to Fisher's, but you know, it's different. So D is special purpose index. This is the final one. So there's four. This is the fourth one. So there's 4 indexes actually, not 3, not 2. One of special purpose indexes is the consumer price index. You should have, I don't know if you've heard of this before, but okay. Consumer price index measures the change in price of a fixed market basket of goods and services from one period to another. And the function is, it allows customers to determine the degree in which their purchasing power is being eroded by price increases. So CPI, which we often say it, you can kind of see inflation from CPI. So it's kind of useful. It's not kind of useful, it's very useful. So model 5 exercise, I will discuss this now. So there's no homework this week. Problem 5.1, you're given a set of data and you're supposed to do this first. Yeah, fill in the table before you can compute any of the indexes. So I guess I just have to show this because, you know, it's just multiplication. So P0 times Q0, you get 800 times 10, 8,000. And you do the same thing for beef, fish, and pork. And for PT times QT, it's 14 times 1025. Then you get 14,250. And you do the same thing for beef, fish, and pork. And P0 times QT is basically price from 2019 times quantity of 2020. You get 10,250. And for PT times Q0, you get 11,200, which is by multiplying the price from 2020 with the quantity from 2019. Okay, so number 2, you're supposed to compute a simple aggregate price index. So how do you do that? You add this all, which is basically 72, and you add this all together, which is basically 55, right? And then you divide 72 by 55 right here, times 100. It's supposed to be 100, my bad. So the index number is 130.9 if you use a simple aggregate price index. But they ask you also to compute last Paris price index for 2020. Remember, for last Paris, we use a Q0, not QT. So we have counted them all here. PT times Q0. PT times Q0 is here, right? So add them up. It's 41,220. And Q0 times Q0, you add them all up. That's 31,130. And then you divide them all. You divide 41,220 by 31,130. You get 1.324 and then times them by 100 because you want to make it into a percentage. You get 132.4 for the next number. And now Pasha, use PT times QT. You sum this, which is basically 55,000. My bad, my writing is quite bad because I'm using a mouse to actually write this. So, and then you're supposed to find P0 times QT, the sum of all of them, which is 41,810. And then you divide 55,250 by 41,810. You will get 132.15 as the index number. Right, now we have to find Fisher's ideal index. Just multiply Pasha and Las Perez, and then you square root them. Then you'll get 132.275 and determine a value index, which is basically just 2020 as a whole compared to 2019 as a whole. You'll get this, right? 177.48. Now, problem 4.2. For this one, it's a bit different. You are given more than 2 years. So in questions like this, you are given the year which you will use as the base period. It doesn't have to always be the longest year away from the present. It can be any year actually. So read the question carefully. Use 2018 as the base period, right? And for number 3, you can see use 2019 as the base period. So every number may have a different base period. So be careful on that specifically, because it might mess up your question, mess up your answers, right? So problem 4.2, if you have already known the base period for everything, it's basically easy, right? So for number 1, you are supposed to calculate simple price index for each item. So for burger, hot dog, and sandwiches, just find them all, PT divided by P0, because 2018 is the base period. Use data from 2020 and divide them with the price from 2018. So for burgers, 4.6 divided by 2.5 times 100, 158.62. And do the same thing for hot dog and sandwiches. I don't think this is quite hard, so I'll be moving on to the next one. Right, simple aggregate price index. So if you still remember, it's the sum of all the prices in each in the designated year, which is 2019, and the base year, which is 2018, right? So sum of prices in 2019, and this is the sum of prices in 2018, right? It's not that hard. So 11.35 divided by 8.85 times 100, you get 128.2.5. Right, now you're supposed to finalize Paris price index for 2020 using 2019 as the base period now. So for this one, because midterms MCQ, you don't have to write. I don't know if it's MCQ or not, but if it's MCQ, you can just use Excel to calculate this one because it's quite time consuming. So if possible, just use Excel for this. I don't mind, right? For this one, I'm just going to discuss it directly, right? So PT times Q0, which is this, and then you sum it. It's basically 41,847.5. And for P0 times Q0, you have to find them for each items, and then you sum it. Again, 30,000, 262.5, and then you divide this one by this one, okay? 138.28. And for Pasha, it's just a different way of multiplying the data. So it's P0 times QT and PT times QT instead of P0 times Q0 and PT times Q0. So yeah, remember that. For Pasha and Las Perez again and again, I remind you to please remember the difference. Right, so PT times QT, and then you sum it, 41, 182.5, and for P0 times QT, that's 34,401. And then you divide this and this, you get 122.62. And for Fisher, just multiply Las Perez and Pasha, and then you square root it, and you get it. You get 130.22, right? And determine the value index using 2018 as a base period. So just multiply price and quantity for 2020 and multiply price and quantity for 2018, sum them up. 42, 182.5, and this one is 19,052.5. Sum them up, all right, and then divide this by this. You get 221.4. So that's it for today's lesson. Don't forget to fill in your absence not absence, my bad, your attendance, and see you next week. Thank you very much for your attention, guys.